Hello everyone. I hope you all are doing well, and good morning. Today,
Good morning, sir.
good morning. Today, I planned for a short demonstration regarding the concepts which we were discussing yesterday, and some of the advanced concept, I guess, which we haven't discussed until now, but some of the students, I guess, wants to they want to have a demonstration that how we will be having practical sessions. So today I will be doing a short demonstration uh, and a case study. So this case study belongs to healthcare data set. So what we are doing, we will uh, be analyzing the data of Alzheimer disease patients who are suspected to having Alzheimer and ultimately having dementia. It is one of the largest well-known disease and is a cause of death of majority of population around the world. So uh, yeah, sure. I'm just giving the background, what is gonna be about and what is Alzheimer. So as you can see over here in this slide, a brief introduction. Alzheimer is a neurodegenerative disorder of certain cause which causes dementia. So dementia ultimately leads to the death. So there are a lot of patients around the world who are suffering from Alzheimer, and at some stage after a certain age, uh, and they will die because of this dementia. So it is a neurodegenerative order in which our brain tissues will get shrink and ultimately dead. So we will be analyzing such data set, and the data set is about the MRI. So MRI actually is magnetic resonance imaging scan of our brain. So we will be analyzing MRI data of 150 patients within an age group of 50 to 90 years. So I'll be waiting for 2 more minutes. Let everybody joins, and then we will start. So I hope that you all will get a proper understanding of yesterday's lecture. Amandeep Singh and Hari Babu, uh, were you all clear from yesterday's concept which we discussed?
Yes, sir, a little bit.
A little bit. Okay, so today you will get some more understanding of those practically, so you will understand and you will have a better idea.
Yes, sir. Actually, I don't have any coding experience in the
Okay.
past. So
Yeah.
that's why I found difficult yesterday.
Okay, so you haven't done coding before.
No, I have done, but it's been like 5 to 7 years since
Oh,
I learned coding. Then I didn't get any chance to, revise and
yeah, that's not a problem. It's like, as I told before, it's like pretty simple. Python is not very difficult. Even if you revise here what I am teaching, if even if you go and revisit those recordings of the session, you will easily understand, and you will not be required to use more than that what I have been teaching in lectures, right? So only that part you just need to go through, and it will be all refreshed, and you will be able to code again. So that's not a problem. All
Mm.
right.
Okay, okay, sir.
Yeah. So we have here uh, Nagaraju. Okay, I think Hari Babu has left, or he's trying to rejoin something. So as I was telling that today we'll be having a demonstration about uh, MRI data of patients. So this application is actually belongs to healthcare industry, where doctors and clinicians use exploratory data analysis and use different Python libraries, as I told before, for visualization to better understand the relationship between different variables involved in these data sets, especially MRI data, which I'll be presenting today. And then they use machine learning to fit a model and simply predict uh, it beforehand. Okay, so we will start now. So let me show you the data first. So we'll be using so we will be using this data set, right? So in this data set, this is a CSV comma separated values over here, you can see. So first column is subject ID, that is the ID of the patient over here. Then second column is the MRI ID, which is the ID of the MRI scan done of the patient. Then third one is the group. Group means either that patient has been classified in a non-demented group or demented group. So the patients which are in the class of demented, so it means they are having dementia, so they are positive, and non-demented ones, they are not having dementia, so they are negative, right? So visit is actually the visit to the hospital. So one means first visit, two means second visit. So there are two or three visits for each patient, but we will today be covering only first visit uh, data of all the patients, and then we will analyze everything, features, or you can say columns of this table, right? So then we have MR delay. So it is also one of the readings from the MRI data. Then male, female, gender is here. Then hand means either they are right hand or left handed. Then their age. Then EDUC is actually the education, number of years of education they have done. Then SES, social economical status. Then this is important. MMSC is mini mental state examination. Then we have CDR and ETIV. ETIV is total intracranial volume, then whole brain volume, because these parameters are actually the readings which comes from an MRI scan. So these are important features in order to fit a machine learning model over this data and to predict based on these features that whether a person belongs to non-demented class or a demented class, right? So this is how doctors use the data in actual scenario in healthcare industry to predict whether the patient is will be having dementia in future or not, or what are the chances, or what is the probability of having dementia, right? So this is the data set we'll be using. So let's load this data set first. So I'm just writing the comment also here just to make sure that everybody understand. So we are loading the data set first. So for that, we just use pandas command over, and that is pandas, and we'll use read CSV function over here, and we'll just give the name of this uh, data set CSV file. So it is in the same directory. So there's no need to give the full path. So if you press Shift Enter, so it means no error, means the data has been successfully loaded, and you can just check data.head, right? Head is a function which gives you the 5 rows, and data has been successfully loaded in this data frame, right? So data is just nothing but a data frame, means a table or 2D, or you can say matrix or table, whatever you can say. It's a two-dimensional data structure of pandas library. You can check online about this. So pandas have two types of data structure. One is sequential, and other one is uh, two-dimensional. One-dimensional is series, and two-dimensional is data frame, right? So we got all the data in this data frame, right? Now what we do, because we will analyze the data um, of first visit of all the patients, so we will filter this whole data, right? So if you can look the data, this is the whole data, right? So this is the whole data. It has how many columns, how many rows? 373 rows and 15 columns. So 15 features and 373 unique rows, right? So what we will be do, we will just filter this data over here, and we'll be using only first visit data. Otherwise it will take a lot of time and it will not be able to complete this session. So what we do, we just filter this data based on the visit column over here, as you can see, right? I And for that you will be using lock. This is a lock is actually mm, a method which filters the data based on the value of a certain column. So how you specify the value over here? So it is just simple as like visit. Visit is the name of the column. You just specify this data frame and the column name and which visit you want. So 1, 2, 3. So I'll be using data first visit, right? And this is how, if I press Shift Enter, so the data is filtered now, right? So it only contains first visit, not second and third. And you can check this out here by this. So if you print the data, you can see only one is here. That is the first visit data is here, right? So now after this filtration, we need to do some adjustments. So I'm just writing the comment here, some adjustments to visualize, right? So what adjustments we need to do over here? First, you can see that this male female is a categorical data, and we will be using this particular column as a feature in for our machine learning model. So we need to change this labels into some integers. So what we need to do, we need to do encoding. We need to do encoding here, encoding of male slash female column, right? And how we will do that encoding? We'll use replace function for that. Simply just type data males column name, and then again you have male female, that is a column name, and you need to use replace function for that, right? And you need to specify it as a list of values. So whatever is the value of this column is here, and with whatever encoding you need to replace it should be in this second list. So replace function will take two arguments. First list is the value of the labels or classes. So this is the male class and this is the female class. So patient could either be male or female, right? And you can replace that labels with some integers. Like I'm gonna replace male with 1 and female with 0. So I will just write it 1 comma 0 like this. So this is how the replace function works, right? So we got an error here. And what is the error? See the caveats. Okay, so it's not the error, just like a warning kind of thing, right? So we can check out our data now. So what would be the data now? You can check now. The male female column contains 1 0 0 1, not M or F, right? So we have made this adjustment over here, and we have done the encoding part, right? So hot encoding, you can say, or you can say simply encoding of this particular column with these values, integers, because otherwise we won't be able to fit a machine learning model over this categorical data, because this is a categorical data. We need to encode this, right, if we want to use this as a feature. Similarly, we need to because this group would be the output of that machine learning model. So that machine learning model will predict either patient belong to non-demented class or a demented class. So we need to encode this column also, right? So I'm just writing here encoding group column, right? How you can encode that group column? Same way, just type data group, and we have, again, you need to change, you need to use replace function to replace the values with two sort of argument with two list. So first list contain the value of the group. So what is the value of the group? uh, Also, if you look at this, before I do that, just let me show you, there is one more class in this group. And if you see, there is one, if you have observed, there's one converted here, right? So it is a third class, because we have filtered out the data, right, on the basis of visit. So converted means initially this particular patient with subject ID this was non-demented, but after first visit he was diagnosed with dementia or Alzheimer's. Then his status will has been changed to converted. So what we will do, we will just change this converted to demented, right? So it will be easier for the model, or to, it will be easier for the problem to understand for you all people, right? So we will keep only two classes as the output of the machine learning model. One is demented and another is non-demented. So we have to change this converted value throughout the whole uh, table or whole column to demented, right? So how can we do that? Again, uh, we need to use, so first what we will do, before encoding we need to replace converted status to demented status, right? So you can simply do that like this. As I was telling before, you need to change the group column. So it is like group here, and you need to use replace function again. And then replace function, how it will be changed, you need to give two arguments. So replace function will always take argument in this format, to list, whatever is the value. So this is the value which you want to replace with this value, second argument, right? So we need to change converted to what? To demented, like this. You got my point, right? And if we execute this statement, so, and we can have a look how the data looks now. See, now the group is containing non-demented or demented, right? For this particular 20, it has been demented now. The data value has changed to demented from converted, right? So now what we have to do, now we encode this group column, right? So I will be taking demented patients as one, right? So I'm writing here demented, sorry for the spelling mistake, demented as 1 and non-demented as 0. All right. So again, use the replace function here, specify the same way group. Then we have a, so what this represent? This is a column value, the whole column, or you can say column vector, right? So we are putting replace function over this, and we simply replace like we did for male, female. We'll do it with demented and non-demented. So demented and non-demented. And what we will, how we will replace demented with 1 and non-demented with 0. You got my point, everybody? Right? Demented, we are encoding demented class as 1, binary 1, and non-demented by binary 0. Right? And if you look now, the data, see, group contains 0, 1, 0, 1, not demented, non-demented. Right? So we have changed, we have encoded until now this column male, female. We have filtered out the data. We have converted that converted value to, we have um, um, reduced the number of classes from the output column, and then we have encoded it to 0, 1. So now from this model, from this data, if we fit a machine learning model over this, then machine learning has to predict only 0 or 1. 0 means non-demented and 1 means demented. So machine learning will, if you supply a test data after it gets trained, so on supplying the value of whatever features we will take into consideration, it will predict either 0 or 1, only two classes. So it basically, it is a classification problem, classification supervised machine learning problem, right? And we are analyzing this data. First, we are understanding the relationship between each of these columns, or you can say features, which are responsible for the prediction, or which are responsible for solving this problem of predicting early Alzheimer, or predicting an Alzheimer at an early stage of patient before. Uh, so the more early it is predicted, the better it will be for the patient. So the doctors can cure that patient early, or the treatment can be started at early stage rather than at the last stage, right? That's the essence of the problem over here. So now what we do, we just remove some of the useless column or unnecessary columns by simply using drop function, right? So these, all the functions are pandas functions, right? So you need to specify which columns you need to drop. First, I'm gonna remove hand. It is useless for me. Left-handed or right-handed, it's not required, right? Similarly, MRI ID, and also we will drop visit, right? And we need to specify the axis over here. So we'll be removing the whole column, so it will be 1 here. So if you are removing columns, it is 1. If you are removing rows, then axis will be 0. And see, now if you look out the data dot head, if you print the head, you will get only these columns. There is no visit, no hand, no MRI ID, right? So we got this consolidated, this adjusted data now, right? Also, now if you see, the data has been filtered actually at this very first step over here. This is the filtration step based on the visit column, right? So we need to sorry, we need to re-index the data, right? Because if you look at the indexes here, 0, 2, 5, 7, 10. So you need to re-index data dot reset index is a function which can easily reset the index of the data, and you need to assign it to the data. Right now the data has been resetted, its index has been reset, and you can check, like print the data. See, now it is 0 1 2 3 4 5 6 7, right? All the rows which has been removed from in filtered rows has been removed, and the index has been reset with this function of pandas library. Now we have group column encoded, male female column encoded, right? And the data set, the data has been re-indexed. Now what we do, so I will now we will see, we will try to analyze the data. So we'll do some exploratory data analysis now, right? So let's count the number of patients from this data. Let's count how many patients are demented and how many patients are non-demented. So number of demented and non-demented patients, right? How can we do that? So we will simply make a variable demented count here, and we use the data frame named data, and then we make use of this group column, because group is the actual value which tells you if it is 0 then it is non-demented, if it is 1 then it is demented. So we will be comparing this with 1, right, over here. And what, and also we want over here number of demented males and females, right? Non-demented males and females, right? So basically we are plotting a histogram or a graph which shows how many male patients are demented and how many females are demented. Similarly, how many males are non-demented and how many females are non-demented. So what we do, we just specify. So this is the column name over here, and this is the actual condition of being demented and non-demented. So this condition means either it is male or female. We will classify, or we will pick those records from this table which are being demented. So that's why we are putting it to demented count, right? So this will give us, if you use a function over here, that is value underscore counts. So this will give us demented count. It means all those patients who are demented, right? It means who are having value 1 for this particular column. All those records will be counted and stored in this variable, right? So you can have a look what this variable contain, demented count, right? So 40 plus 38, so it's like 78 in total having dementia. 41 means that we have classified males, if you look at males, by 1 and females as 0. So 0, it means female, 38 females and 40 males, right, are having dementia. Similarly, if we check the non-demented count, same way, just copy from here and paste here, and you need to specify just 0, right? 0 means non-demented, and rest of the instruction will be same, right? And check this, what is the, so 50 males and 22 females are non-demented, right? Now we can also plot a graph over here. using uh, the same values we have used. So we will plot a uh, bar, or you can say, okay, yeah, bar plot would be fine for this. So we will use pandas data frame over here, and we will pass these two values like demented count and non-demented count over here. These variables contain the actual values, actual count, right? So it's very simple. You just need to set this data frame to this variable, right? And then you need to set the index. Index means for the bar chart or bar plot. So bar plot dot index is a function, or a property, where you can just specify the, so one class is demented and another is non demented, right? So we have set the index. Now we can just plot bar plot dot, we can use plot function, and kind of plot is bar. And one more thing, because we are having male female as well, so we need to give stacked equal to, sorry, capital T, as I told you yesterday as well, right? If you hit the enter, see, this is the nice graph here. So until now, if you look at this graph, this is for demented ones and this is for non-demented ones. So zero means male, right? And one means female, right? So if you like look at this graph, so this blue curve over here, um, in this category of non-demented patient, so female, this is the females, so 50 females and rest are males. So what does this particular graph signifies, what it means, what you can understand from this graph, what it tells? Basically it is telling you that uh, number of females are higher, and over here they are almost same, but if you look at the values, it's very close. But demented there are 40 male, sorry, uh, it's okay, so male is one, male is one, okay, so 40 males and 38 females, right? So these are males and these are females, right? So males are higher than, and over here females are higher in number than males. So what does this graph means? That males are more likely to are more likely of having this disease, and females are less likely. It means male is more probable to have dementia in comparison to female, right? So this is the analysis of this graph. Males are more probable, or you can say more likely to have dementia than females. Okay. So I would like to ask questions from all of you. Uh, you can type in chat over here. What is that you don't understand over here from the very first line? Please ask me. I will explain you. Is
Yeah,
everything clear?
yes, sir. But what is the meaning of panda dot read CSV? What is CSV?
Okay.
Pan-
Okay, it is actually a function. So read CSV is a function in this library. It is predefined Python function, uh, which is used to read CSV data. CSV means this type of data, cross comma separated values. So these are the columns and these are the rows. So it's a two-dimensional data and CSV data. So for if you want to read CSV data directly in single variable in Python, so you should always be using this, right? So this is a function. This is a Python function, or I can simply
Okay.
write over here uh, a Python predefined function used to read data into a, a two-dimensional data structure known as data frame. Okay.
Okay. And
And
what is import seaborn?
it is actually a library. I will show the use of this. So like this over here. So it is used to plot um, or visualize the data. So I will show you in 5 to 10 minutes how it is used. So it is a
Mm-hmm.
Python library which has functions like this. So it has its own predefined inbuilt function which are used to plot these data, or which are used to actually analyze the relationship between columns, right? So Seaborn is a library just like Matplotlib, Python library.
Okay. And sir,
Yeah.
when you write data.head, then why did it show only 4 columns?
Yeah, because it is designed to do like this. Head is just to uh, get an overview. It is not designed to print the all number of rows. So it just by default print 5 rows only,
Okay.
right?
Mm-hmm.
So head is just to see how it looks like. It's just a sample of how it looks like. So you can head means just 5 rows and all the columns will appear here, just to see how actually it is populated, a sample of data from this whole data, right?
Okay.
Yeah.
Okay.
And this is lock is used to filter out the data. Filter means like over here, this is a condition actually, right? So this means data visit means this column visit, when it is 1, then it will take that all those value where visit is equal to 1. It means all the records, all the rows which are having this particular visit 1 will be filtered and will be assigned to data, or you can say uh, sorry, yeah. So all the rows which are not equal to 1 will be removed, right? So did you get this one, how we have encoded, why have we encoded
Yes,
particular
yes,
column?
this was clear. Replace one was clear. At the last, can you scroll down a bit?
Yeah,
Uh, last, uh,
this one.
yes. Why did you write a stack is equal to true?
Because we are having two different classes, because male female, otherwise it will not appear. So these are like stacks. So this is first class and this is the second class. So we need to show 4 different categories, no? Like one is demented and second is non-demented. So within each class we are having male and female, male female, male female, right? So
Okay.
that's why it is stacked. Stack means one over the top of the other.
Mm-hmm. Okay. And above this, like bar underscore plot, and what is this whole statement? PT dot data frame.
Yeah, so it is basically because you are counting the number of values for 2 classes, right? So demented. So demented means when it is 1, so you are having 40 40 males and 38 females, right? So this
Mhm.
is actually a kind of series. I will tell you later on what this is, a type of data structure used in pandas. So it is a series which is having two values, 40 for males and 38 for females. Similarly, non-demented is having 22 males and 50 females, right?
Female.
So PD is actually that library pandas over here. If you look, import or uh, it's like or you can just write like this, pandas over here. So if you execute this, so you will get everything over here in this variable in the form of a data frame. So it creates a data frame, right?
Mm. Okay.
and this is data frame is just like a table. So we are having four variables: demented, non-demented, male, female. Four variable. If you plot even a table, so it will be having two rows and two columns. So similarly, it is just plotted as a graph over here, right? So you will get understand once I will show you the Seaborn, how it works actually, how we analyze this relationships, right?
Okay.
So any other questions to anyone, so that we can start now with Seaborn, how actually Seaborn works. I will show you. So using Seaborn, a data visualization library, right? So what we will be doing, we will be analyzing two columns, because we know our output is group column, which is either 0 or 1, and another column that is MMSE, which is as an input. So if you look at this table over here, so MMSC is actually a score in an exam. So each of these patient has given an exam, a cognitive ability, or just like a quantitative aptitude exam. So these are the scores of those exam. Each patient, like this particular patient got 27, this one 23, 28, 28, 20. So what is the general intuition over here? Okay, MMSC, if it is higher, if your score is higher in this exam, it means you are less likely to have dementia. It means your brain is working absolutely fine. If you are having low score, then there is some issue with your brain. This is what it means. So we will just use Seaborn over here, and we'll plot the group, that is the output column, with MMSC as input. So we'll plot the relationship between these two columns using Seaborn. So our Seaborn is over here. So Seaborn dot, we will be using facet grid is actually a function to plot the grids, right? Grid type of uh, data structure, or you can say plots. So we'll pass, first argument is to pass the data which we have loaded directly from this read function, right? So we'll pass data over here, and then there is one argument hue. Hue means x-axis, whatever you want to, or the uh, output column. So here we have two classes, non-demented and demented. So we'll just write the name of group here in hue, right? And then we use function. So it is basically creating an object of this class. So this is a class in this library, Seaborn facet grid, which takes two argument or one more argument. Like I can show you aspect. This is aspect. It is actually the size of the graph which will appear here like this. So aspect is the size. So you will get the object of this class, of this facet grid class, and you have to use then map function. over here. In map function, you need to, first argument is to specify the type of the curve. So we are using, you can check out the official code of Seaborn. There are few types of graphs you can plot. So this is KDE plot, basically a line graph. So just you can consider just like it is a histogram or it's a bar plot. It is just like a line graph, KDE plot. So you will just have a look as I'm just writing it here. MMSC is actually the column which we need as input. So it will come here. And then you need to specify some third argument, which is like for the design of this graph, shade. So it will give shade. It will automatically color like this to different line graphs it will create, right? Now we just add legend. You already know what is legend. Legend is like this. This is a legend which tells you what this means and what that means. And if you write this, if you compile this, you'll get something like this, right? So this is a Seaborn plot, and it is a relationship between or it is the value of MMSC score, this examination score of group 0 and 1. What is group? 0 means non-demented patients, 1 means demented patient. So you can yourself have a look that more number of that non-demented patients are having higher score than demented ones, because dementia, those are having dementia will have their brains not working as expected because of that disease, right? Because of the disease, that graph is too low, right? So this explains what analysis part of this graph, that non-demented have higher MMSC scores than demented ones. Right? So this is a Seaborn plot. This is a line graph, and this shade true actually put the color automatically over here. Any data, same process used. I didn't get, what does that mean, Hari? If you can speak up, or you can type any data, same process. Yeah, of course. It could be, of course, for any data, the process would be same. Of course, the library would be same. Data could be anything, depending. So it is just an example that I am demonstrating here. So that example involves that it belongs to a healthcare industry. You can take data of whatever industry or whatever sector you want to analyze and fit a machine learning to that, right? So similarly, MMSC, we can plot some other, like one more observation. If you can see, this column says WBV. What is WBV? W means whole brain volume. What is the volume of your brain? So if you're having dementia, then your brain volume would be less, and if you're not having dementia, then your brain volume would be higher. Like you can see, uh, uh, so in that case, you need to just analyze it, and you need to plot the same way like I did before. So plot group and WBV relation is just a variable. So just copy this from here and use it same way. Then you need to use map function, and then you need to copy this and just change this MMSC to what? to this, the name of this column, WBV. It's over here. If you look at this table, so it is NWBV. The name of this column will appear here, and shade is true. And finally, uh, it would be adding the legend. Add legend. So you can see this curve. So 0 means non-demented patients and 1 means demented patients. So you can clearly see this is the NBV, WBV. So if you go towards right, so your brain volume will increase, right? So you clearly see this blue curve is going slightly towards right as compared to this orange one. It means analysis over here, non-demented patients are having higher volume of brain, whereas the demented ones are having lesser value because lesser value because their brain cells are dying, right? So this curve means, so this is the analysis or of this graph, right? So this graph shows the relationship between uh, the relationship between these two groups based on this particular feature or column. So basically, it is telling us that the patients which are normal, so normal patients are having normal WBV and abnormal patients are having lesser WBV, which is actually correct. That is a factual understanding. So our data analysis is correct at this point. So anyone having any issues until now, you can ask for this after from here if you want.
So why did we use add legend?
Add legend is just for this part. If you don't do that, you will not be able to understand what is blue and what is orange. So basically, it adds the information for the reader to the graph. That is add legend. This is the legend actually.
Okay. Okay.
Okay. So Hari, are you getting the point? You can use any data and you have to use the same process. So any doubts, please ask.
Sir, KD plot, can you explain? KD plot, KDE plot.
KDE plot is so I don't remember all the plots, but if I can show you over here, that is pandas library, and you have a KDE plot. So it is, if you look at the documentation of this pandas over here, so you're having different types of plot. So this is a KDE and this is also KDE. So you are having a plot.hist, plot.py, and there are a lot of, you need to just check out different types of plot here. So KDE is just simple line plot, right?
Okay. Mm.
You can say, I haven't read this in detail, but you can have a look at this Geeks for Geeks over here. right? So what is KD plot is a use for visualizing the probability density of a continuous variable. So if you so basically what we are doing, we are just estimating the density of these variables like MMSC. This is a continuous variable, right? Because if you look at the table, MMSC are having uh, real numbers, float values, right? 27.0, 23.0, like this. So this is a continuous variable. So whenever you want to find out the distribution of this MMSC, so it will be this KD plot will give you the density estimate, how these values are spread. If you know about normal distribution or Gaussian distribution, then you would probably have a better understanding about that. And I will explain you next lecture in detail. What is We will be, of course, studying Gaussian distribution when we start learning statistics, probability in maths. So then you will better understand what this means, what is density estimation, and what are these plots are doing, right? At this point, you just need to use these tools just to analyze the data you are having, right? Am I
Yes.
clear?
Okay. Yes, sir.
Okay. uh so what else we can do? Like, we have plotted the relationship between group and WBV. Similarly, we can plot a relation between uh this one, no? uh, TIV. This is total intracranial volume. It is also a measurement of your brain, right? Total intracranial volume, TIV. So you can also plot the relationship between this column and the output column, right? It means those who are having this disease, what is the value or what is the distribution of this uh, particular variable. So we can see over here like this. Similarly, I just create a variable, um, plot group, and then TIV, and then relation. Similarly, just copy this from here, same statement. You're getting my point, right? So until here it is same. Then we have a map function. Then we need to copy this from here and just change the input. So what is our input over here? The name of the column is ETIV. And then finally, just you need to add the legend to this variable, like this. Add legend, and then this. So this is the relationship between the two types of patient, either demented or non-demented, with their total intracranial volume. So those who are having zero, so you can see this blue curve. Blue curve is having more. This part over here shows that those who are not having this disease have higher value of this variable ETIV, total volume. So what is the analysis again? I will explain them in detail later on. Non-demented people are having higher total intracranial volume than demented patients. Got it? So this graph shows that those who are suffering from dementia, their brain is shrinking. So you can also say the brain of patients suffering from dementia, or those who are dementia positive, right, is shrinking. So the brain of patients suffering from dementia, a bit of a spelling mistake. Okay. So the brains of patients suffering from dementia, those who are dementia positive, are shrinking, right? So this is the analysis of this curve. So this is all what we are doing. We are doing exploratory data analysis. We are trying to understand the relationship between these variables or input features, right? Also, we can plot a relationship between this column, education, EDUC. What is this EDUC? Total number of years spent in education. Like if somebody has done graduation or BTech, then 12 plus 4 is 16, right? So the value would be 16 years of education. So we are having different values like 16, 12, 18, 12, 14. So 18 means somebody has done PhD like me. Good joke, right? And group is, of course, we are having the output. So we can analyze the relationship between group and EDUC. So how we can do that? The same way, plot group and EDUC relation. Copy this because our output is same, so we're not changing this hue because our output is same. We are just analyzing the relationship between the output, this group column, and all the input columns, other columns. That's why it is not changing. Then you have to use map, then cborn.kde plot. We'll also see different types of other plot like Mandeep asked apart from KD plot, but for this time we are just using KD plot to just show you the basic idea how it works. Then we use EDUC. This is the column input which we are analyzing or finding relationship with group column, right? And then shade is true. Then add legend. So this is the output of this curve. Can anybody tell me what is the analysis of this curve? Any idea about this? Cborn means Cborn is a library actually. It is a library to plot
People,
these graphs.
so
Yeah,
the analysis is key. People with less number of education years are more subjected to dementia. Dementia.
yeah. No, actually, yeah, you're right. But the other way around is like those who are having dementia or who are diagnosed with dementia have completed less number of years in their education or have spent less years in studying or reading than normal patients. Yeah, you are right. This means those who are non-demented have spent more number of years in education, right? So this is because it is also important, you should clearly state your outcome. So this is the outcome of this graph. It should be clearly, because at the end of this all the whole analysis, you need to disseminate, or you need to tell these results. You cannot show the graph to the business users or the stakeholders. You need to write in a plain English what is the analysis is all about, what it concludes. So what is the conclusion? You need to write it, right? So similar manner, we can just do. So this is all about the EDA, exploratory data analysis. We put an end here, right? So this is whole analysis of the data, understanding the data and identifying the relationship between different columns, right? So we have I have written the analysis. You can just check out and the recording as well. What are the analysis, how the graphs are plotted. You can just also I can provide the notebook so that you can make the changes and learn what uh, how it actually works, right? So I'll provide at the end of this lecture this notebook, and you will get the recording from Akash or somebody else, right? So now we need to fit a machine learning model. So before that, we need to pre-process the data, right? So pre-process the data. So at this point of time, we are just interested in removing nulls. So we are having some null values, and how we can identify that? Pandas dot, there is a function is null. If you pass your data to this function and call a sum function, then you will get to know that there are these are the columns: subject ID, group, MR, all the columns which we have shown above here. So if it is 0, then it means there is no null, except this SES is having 8. It means SES is having null values. And how many? 8 null values. Then how you can drop this, how you can rectify this problem? You just need to use a function drop NA, drop null. It will drop all the records, all the rows which are having null values, because null values will make our machine learning model incorrect, right? So I have dropped all the values. And if you execute this function again, after we have dropped the values, see, SES is 0. Previously it was 8, now it is 0. So we don't have any null values. So now data pre-processing ends here, right? Now what we do, we just fit a machine learning. So we'll be using sklearn dot pre-processing. sklearn is again a library. I will explain you in detail. In order to finish this demo, I have to speed up a bit. So sklearn dot pre-processing, or you can say it is not under pre-processing. I have written incorrect. It's model selection. So sklearn.model selection is a library, or you can say a class. This is a library, and this is a class inside this library, which has a function. This is a function, train test split. And I have imported this function to test my data, this data, into training and testing. Because in machine learning, you have to split the data in 2 parts. Training, on which the model will be trained, and testing is the unseen data for which we will test, or we will identify the accuracy of the prediction of the model. Next, we need to import one more library. That is what I have written before, pre-processing. And in that, there is a function or a class min max scalar. So this is for transforming the data or to normalize the data. I will explain you later on what does this mean. Because when you fit a machine learning model, you need to normalize these values of these columns, because you are having different ranges. Like if you see 1987 or 1678, 1678, and here the value 0 point. So all these values are in different format. You need to make these consistent with each other, or you need to normalize them to a same scale. So they are on different scale at the moment. So their measurement is different. It is having, this column is having different measuring unit. This one is having different measuring unit. Each column is having different measuring unit. We need to normalize it in order to fit a machine learning model over this data. Right now, we need to identify the output, because we are using what? Supervised machine learning. And what model we are using? It is decision tree classifier. Decision tree classifier, because our problem is classification problem. We need to classify in two classes. Every input has to be classified in two classes, either having dementia or not, 0 or 1, only binary classes. Classes could be more than 2, right? But for the simplicity, I have taken this approach, right? So now we need to identify y equal to, this is the output label, y is equal to data group. So this is the whole column will be treated as the output for the machine learning model in order to learn. And x is the features which we need to identify. So data, then here we will specify the columns which we will use as features. You probably heard about feature engineering and all those things. So these columns will serve as input to the machine learning model when it is learning, right? So ETIV and WWBV, right? ASF. So what is this? This is the output and this is the input, right? Let me write here, X is the input to ML model and Y is the output labels, because we are using supervised. So we need to specify the input output pairs, as I have told you in webinar also. Now, quickly writing X train, comma X test. I will explain you what these are. Y train, Y test, Y test. And then we'll use this function train test split. And what will specify the XY. So what it is doing, it is just splitting the data. It is splitting the X and Y. So we have created, these are the inputs, and this is the output label, right? From the table, if you look over here, this is the output and rest of them are input. So splitting means we will take, let's say we are having 5 rows over here, 1 2 3 4 5. So let's say we take 3 rows as training and 2 rows as testing. This is what this train test split is doing, right? You can have a look like X train dot, there's a function describe. If you use this will show you the what is there in the X train. So count, if you look at the count value, this is 106. So 106 values, 106 rows are there in the X train. Similarly, you can see X test dot describe. So it is 36 over here. So always train test split the data in this fashion, like training is always higher than the testing, right? So we'll train our model on this X train and Y train and test our model on X test and Y test, right? Now what we do, we will do the scaling, that transforming this scalar using min max scalar. Min max scalar is a class, and we need to fit over there. So what it is this, you just need to just look at, I will explain this later. Scalar. So scalar is actually an object of this class, which is fitted on this X train. X train is the training data. So it is fitted on the training data. And then you can use this scalar object to transform your all the columns of your input, whether it is train or test. So what we'll be using, we'll creating another variable X train scaled over here, and we will use scalar dot one more function, transform. This transform function, it will transform this, it will transform X train to scaled. Similarly, X test scaled, and then scalar. Don't worry, I will explain you. Let me finish this quickly. I'll explain you each and every step, how it is working. So now we have transformed our X, whether it is train or test, both the inputs from training data and test data. So this is the train data X train, and X test is the test data. So both data set have X and Y, input and output pairs. Now we just import one more library, sklearn.tree, and we will import our machine learning model, that is decision tree classifier. So we have imported this, and simple, now we can fit the model like this. Fit a ML model, and let's name this as a model, and we will use this decision tree classifier over here to fit using a fit function, right? And what we will do to fit, we will specify X train scaled, sorry for the typo, and we also need to give the output label like this. So this is the statement which actually train a machine learning model, and using this decision tree classifier. This is a machine learning algorithm which is defined in this Python package. So we have directly used it by importing it over here and using it fit function. Fit actually fit this data on this model and gives us the trained model. So after we execute this trained model, there is one more parameter which goes in, because this is a tree based algorithm. So we need to specify, if you have studied binary trees or tree data structure, so we need to give one more argument, that is maximum depth. 5 means 5 levels of nesting would be there. Like if you assume like parent node, then it is in binary tree we have one node, and then we have 2 child nodes, then each child is having further 2 child nodes. So it will go up to 5 level of nesting, 1 2 3 4 5. This is what it means. I'll explain you later on. Let me finish this. So as I press enter here, right, so it says that X train is not defined because I have taken X small. So now we execute it and see the model has been fit. Model has been fit. Now we can directly calculate the score. You can now you can check the model, what is the accuracy, using a score function, and just pass on X test and scaled comma Y underscore test. So this is the test data. So we have trained our model on training data, and we get the model. This is the trained model, and then we test its authenticity, or its how accurate it is. It will be given by this score function, and will pass the test data, because test data is unseen data. Model is trained on a separate data, and it is tested on a test data, which is not there in the training. So this is the whole idea of machine learning. You just fit on some other data and use it for another data. So this is what the machine learning does. It generalizes the model for unseen data like this, right? And when you hit the enter and you see score, see, so this is the final value. This is the output. This is the accuracy of the model which we have just fit on this MRI data. 86, if you convert it into percentage, so it would be 86.11% accurate. And now you can use this model, because as you have seen that after training and testing, this model is correct 86% times, right? It has accuracy percentage of 86%. So it is well acceptable model, though you can improve this number. You can improve the percentage of this accuracy to 90%, 95%, if you do more data analysis, if you understand more. Like, you need to understand all the variables for that, and you need to improve the accuracy of this machine learning model, or you need to use you might have to use some more advanced algorithms like ADA boost, gradient boosting. There are many, or you can use neural networks, deep neural networks over here. So, but this is an acceptable number. It means that 86% times this model is correct out of 100. If you use this model to predict 100 patients, then it will predict accurate value, accurate answer. It will classify those 100 patients. 86 will be classified correctly, and remaining might get correct or might not get correct. So 86 out of 100 is a good number. So this model can be used by any doctor or a clinician to predict whether a patient will have dementia in future or not. So I think this is a very quick demonstration understanding of how actually these libraries, pandas, seaborn, and work, how we can perform the how we can plot the graph. This is the data visualization. So if I summarize this, so this is basically data loading. We are assuming that we are already given this data collected. We don't have to collect because it is already given. I have taken it from an open source website, and then you need to load this data and start analyzing it after some adjustments, like encoding what we have done here. And then we can directly start visualizing and analyzing the data. So analysis part are here, visualization part are here, and finally we did some pre-processing, though you can do some more steps over here, but I have done very fundamental one, removing the null values. You can also have different formatting mistakes. So the more you practice, the more you will get, right? And then I have fitted the machine learning model, which is the ultimate aim of a data scientist, to fit a model and solve the problem, or solve the problem in terms of prediction. So I think this is the overall demonstration which I have planned for today. And now you can ask all the questions, whatever queries you have, since the beginning to till the end. I will also provide this notebook at the end of lecture. You will get the copy of this, and you can have a look, and you can even install this Jupyter. I guess you all probably know how to install Jupyter on Windows, or if you're using Linux, you can also do that. easily. So install Jupyter Notebook in your machine, and then you can directly edit this notebook, whatever I have been writing, and see how changing things change the results. So now you can ask questions, whatever you have. I'm just I've just wind up this session for today, I guess. So whatever you have, just ask me.
Yes. What are the null values?
Null value is like this one. So see, it's not a number. There is not so you are having many values. Null means when you don't have any value available for a particular cell, for a row or a column. So data, when you collect data from different sources, so there are a lot of chances that you will not get any value for a particular column, for a particular row. So those are treated as null. So we need to remove those null, because null is like insignificant value, and we cannot use them in our analysis and training machine learning on that.
Okay.
And so you got until here these plots. You understand these plots over here, all the analysis part I have written over here, right?
Yes, sir.
And pre-processing simple functions. You can also go to the pandas official documentation. If you look at pandas documentation, so you can have a look on this. You will find all the functions over here, right? Input, output, right? Data frame. So you can look data frame, see all the, like this one. I've used a very few of them. So this one is head, which you were asking me, right? So you can also pass a value. So by default it is 5. If you pass 10, then you will get 10 over here, right? So this one, right? If you pass 10 over here, you will get 10 values. In fact, more than 10 it is outputting. So in this way, you can just explore how all these functions work from this. There are a lot of functions. I cannot cover all of them on my own. You have to go through all these, right? Just take this data. I'll provide the data set and notebook both, and you just try to see, use these functions over here and try to apply them and see how they work, how they present the results, how they modify it. So I'm assuming that from here, is this clear to everybody?
Yes, sir.
Hari Babu, is it clear to Hari? You have any question, Hari? Or Akula, Nagarjuna, Nagaraju? You can also ask questions to me about this particular session. I'll provide all the details or this notebook and the data set. You can also practice, because at the end of the day, you have to practice by yourself. After this session, practice is what makes you, what provides you everything, makes you expert, makes you confident when you will be having your interviews. So you can explain clearly that what does this mean.
So, can we download this Jupyter from Google?
I will provide this. Yeah, sure. Jupyter you can install. Just download the installer if you are using Windows. And for Linux, there is some command. So you can install Jupyter Notebook, and then I'll provide the notebook, and you can run this in your Jupyter local in your local machine.
Okay.
Kula, yeah. So Hari, Kula, Nagaraju, is everything clear to you? You can also type in the chat if you don't want to speak.
Yeah, Hari Babu, do you have any doubt? Akula and Nagaraju, everything is clear to you guys now. Where see, tomorrow you guys have the last demo class. So if you have any doubt, you can ask it right away. If you want to have another like discussion, you can do that as well. Okay, I hope they are clear, Abbas. You
Okay.
can repeat. Okay, yeah.
All right, guys. So see you tomorrow then. And if you have any doubt, just then please make it clear at early stage. Otherwise, it will keep on piling up, and you will not understand the later things. And there is no point of doing it this way, right?
Sir, so do we have to write these code side by side, or how can we practice? I mean,
Yeah, so for that, just go to, you can also have a look at kaggle.com. So you know about this kaggle.com. Just I'm typing it in the chat. So just everybody should visit this website. It's very good, and you can practice some of the open source problems over here. It for this you don't have to install Jupyter. Just need to log in with your account and just start solving or applying concept what I have told here. Also, I will provide this notebook. You can use this one to see by yourself, to get yourself familiar with the notebook environment, how it works, how different commands and all those things. Or I'll provide separate list of commands which is for Jupyter, like adding a new cell, deleting a cell, and all those things. It's also GUI based, so you can do that. So practice on Kaggle, have a look on the problems, try to think. So you need to be a critical thinker and innovative in your solutions. So first, read the problem statements, and then you will be okay. Yeah, Kaggle.com is having everything there. You just need to log in and just select any problem, and it will provide you a Jupyter notebook there in your web browser. You don't have to install it locally, but I'm using it, so I have done it on my machine. So you don't have to install, you can do it online. You just need a laptop or tab, whatever you want. You just need to type, nothing you have to install locally. Everything is on the cloud. Is that your question answered, Akula? And so tomorrow I am expecting you guys. I will ask probably some questions to each of you. Very basic one, what I have taught yesterday and today. Considering both days, I will ask you some questions, very basic one, just to get myself the idea that whether you are getting on it or not, or I'm just keep going, or also I need to understand if I have to reduce my pace or anything like that. Is that okay with everybody?
yes, sir.
Okay. All right. Then I will be winding up this, and we will meet tomorrow then. Thank you all. Right.
Thank you, Abbas.
Okay. Bye bye.
Thank you.